In this lesson, I'll show you how to calculate percent yield. The question reads, on a space shuttle, lithium hydroxide is used to absorb exhaled carbon dioxide from breathing air to form lithium carbonate, and the chemical reaction is shown underneath. What is the percent yield of lithium carbonate for the reaction if 50.0 grams of lithium hydroxide gives 72.8 grams of lithium carbonate? As you can see, the formula for percent yield is shown underneath, and we have the actual yield at the top and the theoretical yield at the bottom. We've been given the actual yield to be 72.8 grams. So we already have the numerator of this fraction. What we're looking for is the theoretical yield. And to do that, we first need to organize our numbers. So we're told that we have 50.0 grams of lithium hydroxide. I'll write down M is equal to 50.0 grams. From this number and from the molar mass, which we've yet to find, we'll find the amount of moles, which we'll represent by the letter N. Using the moles, we can then create a mole ratio between lithium hydroxide and lithium carbonate, and then find the number of moles of lithium carbonate, and from there, find its mass. In case you're confused, here's what I mean. We have a periodic table underneath, and from this, we can actually find the molar mass of LiOH. So I'll turn on my calculator. The molar mass of one lithium atom is 6.94, and you can see that right here. Plus, we also have oxygen, which is 15.99. I'll just round that up to 16.00. Plus, one hydrogen is 1.01. Adding this up, we end up with a molar mass of 23.95. Let me write that down. The molar mass is 23.95 grams per mole. Using the mass and the molar mass, we can actually find the amount of moles. So I'll write down 50.0 grams, and I'll multiply this to the flipped version of this ratio. This is a ratio because it's a comparison of grams per mole, but there's no rule that says we have to put grams at the top. We can put 1 mole at the top and 23.95 grams at the bottom. And by placing the gram unit at the bottom, the gram unit here and this one will cancel out. So using our calculator, 50.0 multiplied to 1, which we don't necessarily need to write because it's 50, divided by 23.95 gives us the amount of moles to be 2.0876. We need this to 3 significant figures. But rather than rounding right now, I'll carry a few extra digits. So 2.0876 I'll write. 2.0876. And remember that it should be 3 significant figures. So that is the amount of moles of lithium hydroxide. And notice that it's a 1-to-1 ratio, which means that the amount of moles here is equivalent to the amount of moles here. So N is also equal to 2.0876 moles. Using the molar mass of lithium carbonate and this number, multiplying them together will give us the mass, which is what we're looking for. And the mass that we find is the theoretical yield. So once again, let's go back here. This time we're looking for LiHCO3. The molar mass of one lithium atom is 6.94 plus 1.01 for hydrogen. For carbon, it's 12.01. This one's actually wrong. It should be 0.1 rather than 1.0. And for oxygen, we have 3 atoms of oxygen in this molecule. So I'll write down plus 3 times 16. And we end up with a molar mass of 67.96. 67.96 grams per mole. If I multiply these two numbers together, look what happens. 2.0876 moles times 67.96 grams per mole. The mole unit will cancel out, leaving us with the amount of grams, which is the mass. So the number on our screen times 2.0876, and we end up with 141.87. We need this to 3 significant figures because remember, this number was 3 significant figures. We end up with 142. So the mass is 142 grams. I can finally take that number and substitute it into this formula. So I have 72.8 divided by the number that I just found, 142 times 100%. Both of these are in grams, so our percent yield will not have any units other than percent. 72.8 divided by 142 gives us a percentage yield, multiplying that by 100, of 51.3. 51.3%. And there you have it. That is how to calculate percent yield.